So the first step tells us to pour distilled water into the burette and allow it to drain. And the reason why we do this is so that we make sure that the only thing that we're going to be using is our titrant and there aren't any other contaminants. Okay, so I pour it in. I've got my trash can of a beaker right there. I'm going to turn the stopcock parallel to the burette. I'm going to allow that to flow out. The next thing that I need to do is I need to pour in whatever my titrant's going to be. Well, in this case, because I know the concentration of sodium hydroxide, it has a concentration of 0.05 molar. That's going to be my titrant, so that's what's going to go into the burette. Okay? So I'm going to wash the burette out twice. I'm going to use a funnel just simply to make pouring easier. Okay? I'm going to do just a little bit of the sodium hydroxide in there. And the purpose of this step is to make sure that I get rid of any of the water that's in the burette to make sure that it doesn't dilute out the solution. Okay, so I'm going to let that run out, and as soon as that's done, I'm going to pour it in a second time in order to make sure that the only thing that's in my burette at that point is my 0.05 molar sodium hydroxide. Next, what I'm going to do is I'm going to pour in the sodium hydroxide, and I'm going to actually fill it up to the top and leave it because that's what I'm actually going to measure. So I'm going to pour it in the top. If you notice, if you pour too much, you might notice when you're doing this, if you pour too much into the funnel all at once, it'll get backed up. So just be careful to pour it in slowly, or else you're going to have overflowing sodium hydroxide, which we just never want, okay? So there we go, it's full. What you can do now, what we've done a number of times, is measured volume. Remember, you're reading it like a ruler. The burette starts at 0 and then it goes down. So you'll measure it just like a ruler with 0 at the top and then reading it like a regular ruler. Okay, so I've set up my burette. Now the next step is to measure 15 mils of acetic acid into the flask. All right, and then I'm going to add 2 drops of whichever indicator I decide is necessary, and I'll talk about that in 1 second. Okay, so I'm going to measure out 15 mils of my acid. I don't know the concentration of my acid, and that's the whole purpose of this. Okay, so I'm showing you measuring out 15 mils. Obviously, you're going to have this on the table so that you can look at the meniscus. Okay, and then you're going to pour this into your flask. Okay, so I'm going to pour it into my flask. At this point, what I have is my weak acid and my strong base. Now, in order to see where my equivalence point happens, which we call my end point because that's a color change, I have to figure out what type of indicator to use. So when I'm thinking about this, I've got a weak acid and a strong base. So just as a review, if you have a strong acid and a strong base, when you have equal amounts of them, that's your equivalence point. And at that point, if it's a strong acid and a strong base, your pH would be 7. So you need an indicator that changes color right around a pH of 7. If you have a weak acid and a strong base like we have in this case, then at your equivalence point, your pH is going to be basic. Your pH is going to be larger than 7. So when you come into the lab, you need to look at the indicators that I've provided to you, and you need to find an indicator that has a pH of greater than 7 when it's at the equivalence point. If instead I gave you a strong acid and a weak base, at their equivalence point, the pH would be less than 7. So again, you would have to look for an indicator that changes color when the pH is less than 7. But in this case, I'm not telling you what indicator I'm using, but this indicator changes color when my pH is greater than 7. Okay, so I'm going to add 2 drops into my flask. Okay, I'm going to swirl it. And then this is just a regular titration. You've already done titration with redox reactions. Okay? Remember, before I actually get started, I poured my sodium hydroxide in here. Make sure, before you measure the initial volume, make sure to turn your stopcock so that you don't have any air bubbles that cause your volume to be off. Okay? So I'm going to remove my trash can, and now I'm going to start titrating. Remember, you want to start adding slowly, and if you see absolutely no color change at all, I'm going to scoot this up. If you see no color change at all, you can add a little bit more quickly. But as soon as you start to see it changing color and linger a tiny bit, make sure to add dropwise. So again, and the other thing for you to know is once you decide on your indicator, you'll know what color it changes once it's at its equivalence point. So I don't see any color change initially, so I'm going to just allow this to run until I start to see a color change. And as soon as this changes color, that's when I know, right when it turns whatever color it's going to turn, and then it might turn back to the original color, that's when I'm at my end point. All right, so I'm not gonna ruin the surprise for you and tell you what color this is gonna be, because that'll help you determine the indicator you need to use. But remember, when it has slightly changed color, then you'll again measure the volume using it just like a ruler. You'll find the difference, and then you can figure out the concentration of your acid. Since you know the concentration of your base, you know the volume of base you needed to use, you know the volume of acid you used, then you can determine the concentration of the acid that you are using, which is the ultimate goal. And you can also create a titration curve. Now, we're gonna really quickly go back to the very beginning. Before I add any NaOH, I wanna use this pH meter, okay, you'll turn it on, and then it measures the pH for you. So you'll stick it in to your solution, you'll measure the pH. Then with every 2 mils of base that you add, you are going to measure the pH of that solution. Okay, so for every 2 mils of base you add, or for every 2 mils of your titrant you add, you are gonna measure the pH. You're gonna only do this for one of the 2 titrations you do. You don't need to do it for both. So that's why I'm only talking about it now. So for the one that you are assigned, you will measure the pH every 2 milliliters. And the purpose of this is for you to then be able to create a titration curve. Okay? If you measure the pH every 2 mils, you can actually create a proper curve. So we'll share data, but just for one of these, not for both because that'd be a lot of work, just for one of these, you're gonna measure the pH using this pH meter that I'll give you. Every 2 mils, you will measure the pH, and then you will share that data so that you can create 2 titration curves with the data you collected from this lab.